Hello and welcome to Rocket Lab's live broadcast as we count down to Electron's latest mission from Launch Complex 1 here in New Zealand. The weather is perfect for a midday launch today as we make our way through the final pad operations and readiness checks with just T-minus 13 minutes left in the countdown to liftoff. It's great to have you with us again. My name is Sam and I'm here at Rocket Lab Mission Control with Julian Spice for this launch. A mission we've called Insight at Speed is a friend indeed for the confidential commercial customer we have on board.
Thanks so much, Sam. That's right. Today's mission will place a single satellite into low Earth orbit. But at the request of the customer, we'll be ending today's broadcast shortly after kickstage separation, just over 9 minutes of flight time. In just a few moments, our launch team will work through the final go, no-go poll for today's launch from both Mission Control here in Auckland and Range Control at our launch site in beautiful Mähia. This poll is our real-time status check at T-minus 12 minutes. Our launch directors ask each of our operators for confirmation they are ready to proceed into automated launch procedures at the end of the count. From range safety, ground systems, and weather to our operators monitoring propulsion, avionics, guidance, navigation, and control, all stations are pulled for their status.
That's right. We're looking for goes across the board. So let's hand it over to our launch director, Taylor Moore.
Proceeding with the go, no-go sequence, commencing with stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go, no-go sequence is complete. We are T-minus 11 minutes, 21 seconds, and counting. We are go for terminal count at T-minus 10 minutes. At this time, the 3-word procedure is in effect.
There we go, greens across the board, and we're moving ahead with our scheduled liftoff time at 12:53 p.m. local or 23:53 UTC. Now for our viewers across the states, that is 3:53 p.m. Pacific time and 6:53 p.m. Eastern time. Now our target T0 is right at the top of today's launch window, and so if we do need to push back for any reason, we have a 2-hour window ahead of us to reset the clock and try again.
Today's launch will be our 72nd mission from Launch Complex 1, our 4th launch overall this year, and 83rd launch in total for our Electron rocket. That's across both our orbital missions like the one today and our suborbital launches to run hypersonic flight tests on our Electron variant called HASTE. In fact, just last week from our second launch site in Virginia, we sent a mission on a suborbital trajectory that tested a scramjet hypersonic aircraft over the Atlantic. That launch took place just before the weekend and was our 7th hypersonic flight overall with HASTE. HASTE is designed to test technologies at several times the speed of sound as our customers develop new tech to advance hypersonic capabilities for the nation.
But when it comes to today's launch, we'll be reaching orbital velocities of more than 27,000 kilometers an hour before we deploy today's satellite to its 470-kilometer orbit above Earth. And while the countdown continues, let's take a closer look at the Electron rocket getting ready for liftoff. Now, our rocket is a small launch orbital vehicle made up of 2 main stages and a 3rd platform we call the kick stage. This configuration supports Electron to launch payloads that weigh up to 300 kilograms, and whether that's for a single satellite or for a stack of them across dedicated and rideshare missions. Standing at 18 meters, or about 59 feet tall, and just over a meter in diameter, Electron is one of the smallest active rockets flying today, but it packs a pretty powerful punch.
That's right. When fully fueled with kerosene and liquid oxygen, Electron tips the scales at around 13,000 kilograms. Its liftoff is powered by 9 Rutherford engines, each one of them 3D printed at our engine factory in Long Beach, California. Together, all 9 of them at the bottom of our first stage generate over 50,000 pounds of thrust to carry Electron through its first 2.5 minutes of flight. At that point, the rocket's first and second stages separate, and the vacuum variant Rutherford engine on that second stage ignites to continue powering the vehicle. It's practically identical to the first stage version, except for a key difference with its much larger nozzle, better suited to the vacuum conditions of space. It also runs the same battery-powered propulsion system as the sea level version, using high-voltage batteries as an energy source for the electric propellant pumps. You can see those batteries during the second stage burn. They look like a large silver rectangle on your screen before they're jettisoned during a swap-out maneuver performed during flight.
That's right, and at the top of the rocket, of course, is its nose cone, the payload fairing. Now, like the rest of the rocket, this section is made from carbon composite material to make the structure super lightweight yet perfectly durable under those acceleration conditions. That fairing splits open shortly after the first stage is separated, which is when the payload is exposed to space for the very first time after liftoff. Now, we won't have a camera view of that jettison moment, but you will most likely be able to see those two fairing halves fall away on live camera. And then to round things out with Electron, transporting the satellite to space today is our platform within that fairing called the kick stage. It runs its own 3D printed engine called Curie and can be maneuvered and reoriented using cold gas reaction control thrusters. It's trusted to deploy the satellite to the highly precise orbital parameters required on these dedicated and rideshare launches like today's.
And when we say precise, we mean it. The kick stage has a deployment accuracy within mere meters of its target, which is an incredibly complex feat when you're traveling at more than 27,000 kilometers an hour.
Now, for today's mission, there's another piece of Rocket Lab technology that will play a key role in making this mission a success. The satellite onboard Electron will be deployed using a separation system that's called the Advanced Light Band, or ALB, made by our team in Silver Spring, Maryland.
We've actually got one here to show you. This is the mechanism that separates the spacecraft from the launch vehicle once we reach orbit. This one's a bit smaller than the one on today's mission, but the principle is the same. It's non-pyrotechnic, which means it doesn't use explosives for separation. Instead, using a motorized release system to disengage its clamp-like band and send the satellite on its way.
All in all, from liftoff to final stage separation, it's just under 10 minutes of flight time for Electron. But it takes about an hour before the satellite is fully deployed due to the circumnavigation and course correction moves required to accurately position the kick stage and its satellite above Earth. A reminder again that we will be ending the broadcast today after that final staging event, but we will be sure to share an update on payload deployment across our website and social channels when it happens to confirm mission success for Electron's 83rd launch today.
Now, this launch is focused squarely on low Earth orbit, but within our space system side of the business, we've got our eyes and ambitions set a lot further into the solar system. We have a mission to Mars currently underway for NASA called Escapade. That includes 2 of our spacecraft operating right now in deep space, getting ready to be slingshot to Mars later this year to conduct a scientific study of the planet's toxic atmosphere.
And while that mission continues, we're not ready to be done with Mars just yet. We've got a plan for how to deliver a Mars telecommunications orbiter for NASA designed to support everything that the agency wants to accomplish at the Red Planet, from further science and exploration to eventually human travel to Mars. Here's what it looks like. Now, those scenarios might seem science fiction, but we're ready to make them a reality across our spacecraft, rockets, and deep space mission experience.
Yup, in fact, our technology has enabled some of the most ambitious and successful Mars missions in history, including the Mars InSight lander, Percy the Perseverance rover, and Ingenuity helicopter. We've got more hardware on and orbiting Mars than just about any other company, and we're ready to add more with both Escapade and MTO for NASA.
All right, back down to Earth now, quite literally. And we have just 3 minutes left on the clock in the countdown to liftoff for this mission. Now, here's what you can expect once the launch operations team lock Electron down into its countdown auto sequence. At T-minus 2 minutes, Electron will be fully loaded with propellant and will be manually switched to its internal power system, with the flight computer taking over operations.
Within a minute of launch, we can expect a call out that Electron's first and second stages are fully pressurized. Electron's Rutherford engines will ignite, and then when they're at full power, the pad's hold-down mechanisms will release the rocket for liftoff right on T0. We're continuing to track no issues with the weather, the range, the satellite, or the rocket as we get closer to that auto-sequence handover. All systems are currently go for an on-time liftoff at 12:53 p.m. local time. So let's switch over the audio now to Mission Control and listen in to those final moments before launch. Go Electron.
The vehicle is fully on the top part. AFTS is green, enable flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff.
Beginning metro.
Stage 1 propulsion is nominal.
Insight at speed is a friend indeed, and friends, we have left the pad and we're on our way to space. There on your screen is Electron rapidly climbing through Earth's atmosphere as it ascends over Launch Complex 1 with a fantastic daytime view from our cameras. Those 9 Rutherford engines at the bottom of the stage are about to power Electron through max Q, or maximum aerodynamic pressure. Let's listen in now.
Approaching max Q. Cleared max Q.
And there goes the call for max Q. Electron is performing nominally during this first stage burn. We're now hitting speeds of more than 22,000 kilometers an hour at more than 20 kilometers above Earth. Now, our next milestone coming up will be those staging events we talked about earlier. The first one is called MECO, or Main Engine Cutoff, when those Rutherford engines at the bottom of the rocket power down completely.
Once that happens, the first and the second stages separate within a few seconds of MECO. Then, after that separation, the Rutherford engine on the second stage will ignite. So that's MECO, stage separation, and then second stage engine startup coming up very shortly at around T plus 2 minutes 40 seconds.
Stage 1 propulsion holding nominal. Stand by for MECO in roughly 30 seconds.
"15 seconds to staging. Entered burnout detect mode.
MECO confirmed. Stage 2 ignition confirmed.
Stage 2 separation confirmed.
Beautiful work by Electron there. We are clear through MECO and stage separation, and there on your screen is the glow of the second stage Rutherford engine as it continues the mission on to its 470-kilometer orbital target. We're now at T plus 3 minutes into flight, traveling at speeds of more than 80,000 kilometers an hour.
Up next is fairing jettison. That's when Electron's nose cone separates and falls away. Keep an eye on the screen. We should hopefully see those two fairing halves fall past our engine camera.
Fairing jettison confirmed.
There they go, and that was the call out we were expecting. Fairing separation confirmed by mission control. Now we're counting down to hear nominal call-outs from the team, and the mission continues. All is on track for our next milestone, which will be the battery hot swap on the second stage to continue powering that Rutherford engine. That maneuver is expected to take place at around T plus 6 minutes 40 seconds into flight. So we've got a bit of time left for those current battery packs to continue doing their thing.
Stage 2 propulsion holding nominal.
The next major milestone we're expecting to see will be battery hot swap. Since Electron's second stage flight time lasts longer than the capacity of the first set of batteries, the rocket's flight computer will make the automatic switch to a fresh new set when it's time. Once the hot swap has happened, Electron will jettison the old dead battery packs that it no longer needs. You'll be able to see those disconnect in real time. They're the shiny silver packs on your screen there. The jettison happens quickly, so if you blink and you miss it, we should get a call out from mission control at the same time to confirm that action took place.
Guidance is nominal, 200 seconds remaining.
HEB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
And there they go. Battery hot swap is successful and Electron's second stage engine is running on a fresh set of batteries. This new battery system will power the second stage all the way through to the end of its flight time, which will conclude with the shutdown of its engine and separation of the kick stage with the mission's payload. Now, still a couple more minutes of engine burn time to go. Otherwise, all looks nominal for Rutherford and the second stage. We're moving now at more than almost 18,000 kilometers an hour and around 193 kilometers above Earth.
AFDS as saved.
At T plus 7 minutes and 40 seconds into flight, everything is proceeding nominally for this mission. Operators in mission control continue to monitor the vehicle systems closely as we approach second stage cutoff and kick stage separation for the next phase of the mission. We're just a few minutes away from this milestone and the second stage is accelerating well, getting closer to the speed we need to enter orbit at around 27,000 kilometers per hour.
Right, we're coming up on the final actions for Electron's second stage now, with SECO just a few seconds away before we separate the kick stage with this mission satellite. What we're expecting to happen next is that we'll see the engine's red-hot nozzle start to cool with engine shutdown, and that will be our visual confirmation that SECO took place with no issues, alongside the audio call-out we can expect from mission control at the same time. Now let's listen in for that call-out signaling we've cleared SECO and achieved kick stage separation.
SECO confirmed.
Nominal transfer orbit achieved. Stage separation confirmed.
Nice, that was a perfect nominal SECO and kick stage separation for this mission, confirmed across the nets and from what you just saw on the screen moments ago, with Rutherford's engine nozzle cooling down quickly. The kick stage has taken over the rest of the mission now to deliver its satellite to its 470-kilometer target orbit. It first has to complete its journey around the other side of the Earth before the kick stage's engine lights up to circularize its trajectory and deploy the payload to its new home in Leo.
Congratulations to our launch team and customer on the journey so far. As we said before, we'll be ending the broadcast here while the kick stage continues the mission. But we'll share an update to confirm mission success once the satellite has been deployed within the hour.
That's right. Look out for that update across our social media channels and our website at rocketlabcorp.com. Otherwise, thank you very much for joining us for our 83rd launch. We'll be back with you again soon for our next launch from Launch Complex 1. But until next time, this is Rocket Lab Mission Control signing off.